Let's look at some examples of some spatial joins where it's important to consider the cardinality. This one here shows cities and airports. And in this one, a one-to-one cardinality is expected. We're expected to find the airport closest to each individual city. It would be unusual for identical distances. That would be a very rare exception because those would have to be very precise distances that are exactly the same. So in this case here, a one-to-one join works well, where each city gets joined to one and only one airport, assuming that no two airports are identical distances from a city. However, that is possible. Two different airports could be identical distances from one city, and if that is the case, then that field is given a null value. And this null is just to indicate to the user that there's not one particular airport that is that minimum distance from the city, that in this example here there are two. Here's another example of cardinality, and if we once again go back to the example of septic systems and geology. In this, there's a many-to-one cardinality. We can have many points here within one type of geologic polygon. But septic systems that would occur right on geologic boundaries would be very rare, and they could cause problems. So in general, a one-to-one join works well. So that's the join type, not the cardinality. The cardinality to one-to-one join type works well. And we don't need merge rules because there's really not something that would benefit if we use that. However, we would have to keep in mind that if it occurs right on the boundary, then we could get null values as an exception. Here's another example here where we have some roads data and we also have some soil data underneath it. And we want to join the soil. The target table is going to be the roads, and we want to join the soil to that. And we want to say what type of soil these roads are passing over. And as we can see in this example here, for example, 74 passes over 3 different polygons. So we would expect a one-to-many cardinality. So we could do two different things here, right? We could do a one-to-many join, but that would create, for example, here with 74, it would be crossing 1, 2, 3 different types of soil. So we would now actually have 3 different features that would all represent Interstate 74. And that might not be the most useful way to store our data. The other way that we could do that is we can use a merge rule, in which case we say, for the entire length of 74, we're going to account for the fact that it passes over this soil for part of it, this other soil for another part, and this third type of soil for another part. And somehow we're going to summarize that all in one row of the attribute table. So how would we do that? Well, here's 74 again. We can see that we have 3 different sections here. That would be the join count, because that's how many different types of soil it's passed over. And then we can see that we have 2 different numeric values here. So this was everything that was in the highway table, and now we're adding in the stuff from the soil table. We have clay, slope, and then we have this hydrograph number. And so for the clay, what it does in this case is it takes a mean or average value. It uses the mean rule, and it takes the average value of the clay content for each of those layers and reports the mean here. It does the same for the slope. So it doesn't just take the slope along, the slope factor for any of these 3 polygons. It takes a mean or an average of the 3 of those. And that works well as long as we have numeric records, as long as we have numeric values in these columns of the attribute table. But sometimes we have, for example, a text value representing this this variable here, this HYDGRP. And in this case here, the default is to just take the, it's called the first row. Whatever the value of the first polygon is, it just takes that value from the first polygon. But that's not always useful. So we can see what we've done here is we created a new column, which is called HYD join, and this is going to store a list of all of the different soil types that it passes over. So for example, this road 206, which runs here, passes over 3 different types of soil, which are D, C, and C. The one that we looked at before, Highway 74, passes over 3 types of soil. They're all the same, but they're all just listed there so we know what those types are, B, B, and B.